the afternoon. If you're on the West Coast, it's still morning for you. But anyways, hi. Welcome to Live with mssteph. I am coming at you live. Today is VEDA day number 4. Okay, video every day in April. That's my goal. But anywho, so there's some things going on in the hallway. But yes, so I am here getting set up and everything for one of my classes. So I thought I would pop in and kind of let you know what traveling science teacher looks like, right? Because we have different things that we do. We have Saturday program, summer program, traveling science teacher, and our other consulting things. But when it comes to traveling science teacher, you know how I'm always talking about how your average urban student is only getting 40 minutes or less a week. Traveling science teacher comes in to either provide that minimum of at least 40 minutes, because some students are getting, like I said, when I say less, like nothing, okay? And so we're coming in providing either that 40 minutes or something on top of whatever the school is doing. And so we come in, I set up, right? I set up the room today. As you see, we've got a little solid liquid and gas situation going on. For those of you who've been watching some of the videos throughout the week, you know that I've been doing solid liquid and gas. One of the main reactions that I truly believe every student, every elementary school child should know and be able to manipulate and change and kind of rock out is your basic acid-base reaction, which is your baking soda and vinegar reaction. Those are household materials. They should know. Your child should know. If they don't, you can check out some of my videos. I have actually more than some of them feature not only that reaction, but the different things that you can learn and experience from that reaction. And so one of them is the basics of chemical reactions being you combine two things together and you get something new, okay? And for the particular reaction that we've been doing this week, right? Y'all know, if you've been watching this week, you know that we've been able to use the gas produced from mixing a solid and a liquid together to then expand a balloon. My Montessori kids from yesterday, we did a variation on that. Not only did we combine the two together, we combined water with a citric acid baking soda powder, which, by the way, that's what's inside of Alka-Seltzer that makes it bubbly, BT dubs. Again, same basic acid-base reaction combined together and you get bubbles, okay? And so, I've got some other bubbles happening here, which is a different reaction. This is a physical reaction, okay? You see all the things that we can teach just based off of a couple of relatively straightforward materials and relatively straightforward activities. But back to what I was saying, the variation that we did yesterday with our brilliant students was that I gave them the opportunity to change one component, a measurement of one component. They couldn't just go around just changing everything, because hello, that's not a control experiment. Okay, it's not, okay? Unless you change one thing. That's another mindset shift that's important for our folks to understand, is that changing multiple things, that's not a controlled experiment, right? An experiment is when you start with a question, you go through the hypothesis step, and then you go into testing that hypothesis. If you don't set the question and the hypothesis properly, and you don't then come up with a procedure that accurately tests that hypothesis, right? You see how those things need to connect together. But yeah, I gave them the option. They decided they wanted to change the amount of powder per sample, and we did 4 samples with different amounts of powder. Everything else was the same. The liquid amount that we added was the same. The bottles were the same. These bottles are the bottles that I use. And these are bottles. Anybody who knows me personally knows that this is House. House seltzer. Not sponsored, but I just happen to like their seltzer. And so I reuse those bottles. Reduce, reuse, recycle. Earth Day is coming up. That being said, we did a variation, and so we did 4 different levels of powder. And lo and behold, guess what happened? The sample with more powder made the balloon expand the most. Go figure. It was new to the kids, right? But I walked them through the process. We came up with the question. We came up with the hypothesis, and they really predicted. They were like, well, I think the one with more. Fantastic. Well, let's see what happens. We don't get to just decide what happens. We have to see what happens and observe, right? And take measurement of the thing we said we were going to take measurement of, right? So yeah, I mean, I'm here at one of my favorite schools. Okay, I'm not going to name the school because you guys know all my schools are my favorite schools. But yeah, so just want to do a quick visual of this other thing that I found this online. I was looking, I wanted to figure out how to let my students in real time see one of the practice questions. One of the other educators that I work with here, we were going through the practice questions for the New York State science test that's coming up in May, people. Okay, and we were saying, okay, well, how I was really trying to work through how I was going to be able to bring it to the school and demonstrate it, and right, what materials was I going to need? Because this is, I think through all these things. What materials am I going to need? How realistic is it to present it in the classroom en masse? What are the children going to be able to get out of it? Is there material that is used by the other educator that I might not need? And I was able to easily take out, say, the ice. Because for me, walking around Harlem with ice that's an involved step. Okay, that's one less thing I need to carry. Okay, or one less thing I need to try to ask the school to provide. So yeah, so this is what I came up with. Right, this is a hot plate, a pan. So this I ordered, and I paid like, I paid less than $7 for this hot plate. Actually, did I? Let me not lie. It was relatively cheap for this hot plate. Okay, and I specifically wanted a small one because, again, I'm literally carrying this on my back in this backpack. Stuff has got to fit in here. Okay, so shout out to folks who are like donors and folks who are on the support end of things. You know, when you're helping purchase supplies, you're helping purchase things that are reasonable for me. I make a point to make sure it's stuff that I can carry and that we can still execute the lesson. Right, so remember, intention, set intention, plan, execute. Okay, so I set my intention that I wanted the kids to be able to see this project. Plan, I ordered the materials well in advance, had conversations with other educators, and now see, I'm executing this. All right, so I'm here early enough to start the water to boil. Okay, pot, balloon. Okay, this is just regular water sealed with a balloon. You're gonna see a change very quickly. Yes, this is safe. I'm not going to melt the plastic or whatever. I've done this. I did this on Wednesday with the kids in the room. So it's not doing anything that's like dangerous, okay? Do you see the balloon expanding? Again, this is now a physical reaction. The water and the gas that is trapped in this closed system is now expanding to fill up the space. Okay? To fill up the space. Okay? I'm squeezing this because I want to make sure that the balloon is able to expand as much as possible. But yeah, after a few minutes, that will actually expand completely. Also, you know how I am, I test things out because this balloon has been here since Wednesday. I need to make sure that this balloon will expand. If it doesn't, I need to use I need to replace that balloon very quickly before the students come in. The students are downstairs doing a planned activity. The school already informed me that they wouldn't be here at this time today, that we were going to shift things because they have an event happening, which is, again, one of the fantastic things about this particular school. They always have performances for them, all kinds of stuff. It's fabulous. But yeah, so that being said, if this does not function properly so that the kids get to actually see the expansion, due to heat, because we're comparing a chemical versus physical expansion so that they can see the two. This, again, of course, is not a controlled experiment because I'm changing all kinds of things. This is an investigation / demonstration so they can see it, so that should this type of question come up on the state exam and just in life, they have a concept of what's happening and they've been exposed to it before, and they're not having to experience it for the first time in 2D on a computer test. No, they're getting to see it in 3D in real life. So I don't like how this is expanding, so I will change this balloon, but it's still doing what I want it to do, right? It's expanding because of the heat. Another thing that you're seeing, if I take this off, see, you're getting kind of a cloud formation, and then these droplets are coming down. What is this a model of, people? The water cycle. We've been talking about the water cycle. So actually, I was able to find another way to demonstrate and teach the water cycle to students. Super exciting. All right, so that's pretty much it for today for your video every day. It's day 4 of VEDA. Thank you so much for joining me and watching. And as usual, have an absolutely wonderful day.